A wave is a disturbance that carries energy through matter or space. A wave transports energy, not matter. A medium is the material through which a disturbance travels, for example, water or air. Most waves need a medium in which to travel. Waves that require a material medium are called mechanical waves. Electromagnetic waves are an example of waves that do not require a medium, such as radio waves and microwaves. These waves can travel through a vacuum. There are many different types of waves: seismic, light, water, color, magnetic, and sound. Other videos will discuss the specifics of these types of waves. This video will introduce the properties of waves and wave interactions. Here you can see that the water is disturbed by the girl jumping up and down in the tube. Notice that the boat moves up and down and back and forth around the original position. The boat does not have any displacement from the water waves. The motion of the boat is indicative of the motion of the water particles. The water wave moves, but the wave itself is not carried with it. This demonstration reflects the idea that the wave transports energy, not matter. A wave that consists of a single pulse is a pulse wave. A periodic wave is made up of continuous pulses. There are two different kinds of waves: transverse waves and longitudinal waves. Transverse waves, like the one on the top, are waves whose particles vibrate perpendicularly to the direction of the wave motion, such as a water wave. Longitudinal waves, like the ones on the bottom, are the waves whose particles vibrate parallel to the direction of the wave motion, such as a sound wave or a seismic wave. A crest is the highest point above the equilibrium position, as marked by the blue top running through the waves. A trough is the lowest point below the equilibrium position. Wavelength is the distance between two adjacent similar points of the wave, such as from crest to crest or from trough to trough. Amplitude is the maximum displacement from equilibrium. The speed of a wave, v, equals frequency times wavelength. The speed of a mechanical wave is constant for any given medium. When a mechanical wave's frequency is increased, its wavelength must decrease in order for its speed to remain constant. The speed of a wave changes only when the wave moves from one medium to another, or when certain properties of the medium are varied. A constructive interference is an interference in which individual displacements on the same side of the equilibrium position are added together to form the resultant wave. Destructive interference is an interference in which individual displacements on opposite sides of the equilibrium position are added together to form in the resultant wave. Standing waves consist of alternating patterns of constructive and destructive inferences. Standing waves are made up of nodes and antinodes. A node is a point in a standing wave that always undergoes complete destructive inference and therefore is stationary. An antinode is a point in a standing wave halfway between two nodes at which the largest amplitude occurs. There are many real-world examples of waves. Radios, TVs, lights, and microwaves. We can see things because of waves. We can hear things because of waves.